Now, it was discovered by Clyde Tombaugh. I'm spending a little bit of time on this because this sort of says a lot of things. Now, you know the name. Do you know the story of the name?
No.
Venetia Birdie, English girl, 11-year-old. Her daddy, her grandpa was Falconer Madden, who was the Bodleian Library, you know, the Bodleian Library at Oxford University. He was in charge of that. And his brother, her great uncle, was, what was he? He was not an astronomer, he had something to do with astronomy anyway. So, you know, and he was the guy who thought up the names, two names for the moons of Mars, Deimos and Phobos. So naming things was in the family, so to speak. Anyway, Falconer Madden, the Bodleian librarian, I knew this would suit you, Jenny, librarian. He actually was talking one day, read about the discovery in the Times, wherever, and his granddaughter was sitting there, and he said, "What do you think would be a good name?" And she said, "Pluto." Anyway, so he telegraphed a friend who was an astronomer, who also then contacted a friend who was an astronomer in Britain, and then that guy telegraphed the Lowell Observatory, where Clyde Tombaugh was working, Percival Lowell, the guy with the Martian Canals, Flagstaff, Arizona, and he said, "That's a great name," and he loved it particularly because it suited the Roman mythology and things, and the first two letters, P-L, Percival Lowell, Pluto. So he particularly liked that. So it was just a nice. So anyway, it was approved by both the Americans and the British, and the name stuck. And so there you go. So that's how Pluto came to get its name. Now, we all know, and we know from Martin George, that Pluto was demoted. And we always ask the question, why was it demoted? Well, here are the criteria from the IAU saying why a planet should be a planet and not something smaller like a dwarf planet. And the third criteria, it must have cleared the neighbourhood around its orbit. Doesn't mean it goes around sweeping stuff out of the way. It just means it has a superior gravity and mass, enough to command, sort of like dominate the area around it and be so I can't describe it really, but when you read the definition, it's sort of, you clear the area, but that's what they mean by it. So it's got its own gravity to put it into shape, yeah, it's got all those things, but not 3. So it didn't meet 3. It fails the third condition. Now, they're of course debating that again now. Didn't Martin say they were reconsidering the IAU, reconsidering admitting it into the Hall of Planets? Anyway, so although Pluto met the first 2, it didn't meet the third. Now, I want to show you this picture because this is, you know, the barycenter, the centre of gravity. All right, so the centre of gravity with the solar system is inside the sun. The sun's so massive, it's inside the sun. So everything spins around it, but the sun, the actual thing, the middle point that pulls everything into shape is inside the sun itself. So here, it's outside Pluto. And that's largely because, not these guys, but Charon, which is half the size of Pluto. It's 1,200 kilometres, or something like that. Or is it 2,001, I forget. It's huge. And it's half the size of its primary. So people sometimes call it a dwarf planet, a dual dwarf planet, or binary dwarf planet. So, moving on, I'll speed up a bit now. So, Pluto shares features with comets. How do you say, what do you mean by that? Okay, so it sublimates gases from its surface, a bit like a comet. And some scientists think that if you put it closer to the sun, it will behave like a comet. But others disagree with that. Why? Because it's got too much gravity to allow those gases to escape. Its escape velocity is too great. So nothing could escape it really. Some might, but you know. So there's a bit of evaporation going on around Pluto. And some of it is landing on Charon, as we'll see shortly. It may have formed as an agglomeration of numerous comets and Kuiper Belt objects. So in the Kuiper Belt, you've got asteroids and you've got comets. Neptune's moon Triton is larger than Pluto, but they're very similar in geologically and atmospherically. We're going to look at Triton. Triton's very interesting. And it's also a captured Kuiper Belt object. So many Kuiper Belt objects like Pluto are in a 2 to 3 orbital resonance. Now I read about orbital resonance, and I must say I was none the more enlightened after reading about what it meant. But it's to do with the sort of, you've got conjunctions going on. Hello, Mike. Everybody, greet Mike. Sorry.
No one knows.
You've doubled the audience. No. So it's the relationship that the fixed pattern of orbits and the ratio of the speed of those orbits in relation to each other. One thing might do 2 orbits, another thing might do 3 orbits in the same time, 4 orbits, 5 orbits, whatever. And so there's a sort of a harmony, an equilibrium is the best way of putting it, and that's all it means from what I can gather. Anyway, Kuiper Belt objects with this orbital resonance are called Plutinos after Pluto. Anyway, so Pluto is thought to be a residual planetesimal. What are planetesimals? Those things that were left over from the formation of the solar system, bits and pieces, rocks, stuff in the accretion disk, from the original protoplanetary disk, as they call it. Anyway, they say that as Neptune migrated outward, it approached the objects in the early Kuiper Belt, and setting itself one in orbit around itself, Triton. So Neptune had a profound influence on the shape of things around the Kuiper Belt, and in particular, and even Pluto. So I'll come to it. I wanted to show you this picture because it really annoys me. You know how things are tilted over, right? Everything's got an actual tilt. Now, Pluto's, of course, is inclined at 119 degrees, 122 degrees, something like that. But there it is, 122. But the thing that annoys me is, and the same with Uranus. Uranus has got a 97.8 degrees. We're going to look at Uranus in a moment. Neptune's all right. But look at Neptune and look at Earth, similar. But when they go around the Sun, they're tilted like this. So this annoys me because I'm used to things pointing that way. Prograde, going around the Sun anti-clockwise if you look from the north, and the rotation's the same, prograde, anti-clockwise from the North Pole. But they've drawn these sloping that way, which is kind of weird from my way of thinking. I wouldn't do that personally, but anyway. Venus is shown upside down because it's almost 180 degrees the opposite. It feels upside down because it's spinning the wrong way. It's actually rotating east to west and not west to west. So we've got these, now these things, they don't have a profound effect, but they do in terms of magnetospheres and so on, which we might look at. Now, as Pluto moves close to the Sun, ices on its surface warm slightly and sublime and evaporate from solid to gas to form a thin, mostly nitrogen atmosphere. And as it moves away from the Sun, the gases cool and refreeze. And when they hit the surface, they become ices. They're ices. So you get sublimation, solid to gas, and then back down again. You would have done that with, if you heat iodine, say, remember how iodine in crystals when you were a kid in school, and it would sublimate, same thing, same concept.
They explode.
Anyway, the atmosphere may vanish as Pluto moves farther from the Sun. So that's kind of a very strange thing about Pluto. Anyway, that's the inclination of Pluto's orbit to the Sun, as you can see on the top right there. You can see 17 degrees, that's pretty steep. Now, what does all this mean? Because of its inclination and the fact that it takes so long to go around the Sun, it takes months and months of extreme cold. See, one half of the planet is virtually, almost 30% of the planet is in total darkness when it's winter, as it goes around for a quarter of its orbit. So imagine that, 30%. So you can see it here on the lines. So the Arctic area gets all the light. The poles get all the light at those solstices. And the rest is just, anyway. I think that's really interesting. Imagine living in that kind of environment. And that's just a representation of the ratio of the orbits of Pluto for mathematicians.
I can read that.
This shows how Pluto's orbit in red is less circular than Neptune's, and how Pluto is sometimes closer to the Sun than Neptune, which I'll explain to you earlier. So let's move on. Now, sometimes I've just gratuitously dropped in pictures. Why? Well, save my voice, but really because I love artists' concepts and the way artists see things. This one, is a picture of Pluto looking back at Charon maybe out of there, and the Sun in the distance, which even from there was a bit too big. And the icy sorry?
Far too big. It's even smaller than that from Mars.
It's too big. I mean, it's an artist, not a scientist, so because it should be about like Sirius, I think. Barely bigger than Sirius from that distance.
That's pretty.
It is pretty. I love it, and the red. It's picked up all the colours. The hydrocarbons. I'll explain that in a minute. And there's that thing on the right there. Same sort of another illustration. So this is a picture of Pluto's orbit over. It goes over. Now let's see. 2000 goes over 2040, 50, 60 projected orbit. From about 18 something. Since the observations began and its discovery, but before its discovery, they projected this forward and showing you its orbit around, and these lines represented dipping below, remember, the 17-degree incline, dipping below the ecliptic and then going above it.
It's just past the equinox.
Questions? Sorry.
So it goes into Neptune's orbit, but is there ever a risk of collision, or are they
No, different times.
Yeah.
And different times, definitely.
That resonance won't allow a collision?
No.
Resonance?
The way, the relationship between the bodies, the gravitational forces, there's no decay there. Mind you, having said that, Charon will eventually collide. Charon will gradually, things that are tightly locked will lose their resonance, will lose that equilibrium, and will collide with a planet that dominates them eventually.
So Charon will go into Pluto?
Quite possibly, in 1 billion or something years. So anyway, so that's not going to happen, but in that case, but it doesn't mean it won't happen elsewhere. The core, there's a lot of, the thing that struck me when I was reading about this is how much water is out there. You remember that series? What's that series? The asteroid belt.
The Expanse.
What's it? The Expanse. They were mining stuff on the asteroid belt. Well, if we want to get water out there, there's probably so much water it's unbelievable.
The Belters.
The Belters, the Belters. Anyway, so Pluto's about 2,400 kilometres, only less than a fifth of the mass of the Earth, of the Moon. In fact, it's only 17% of the Moon. 22.22% of the Earth. And its surface area is about as big as Russia or Antarctica, which is interesting. Surface gravity is 0.063 G compared to 1 G, which means you could jump a whole lot higher than you could on the Earth. It has 7, these moons, I love these moons. Pluto is much less massive than the terrestrial planets and far less massive than Ganymede, Titan, Callisto, Io, the Moon, Europa and Triton. So it's not exactly a very big planet.
Well, Stefan said if you jump off one of the moons of Pluto, you head out into space.
Well, I'm going to show you a launching place shortly. Just wait. I've got a picture of something that will really blow your mind. And it's on a moon. It's on a moon. But not there. It's a moon of Uranus. So New Horizons got to Pluto in 2015, took all these beautiful pictures. They are planning, to summarise all of that, they're planning a mission. And the spacecraft will look a bit like Cassini, will be like Cassini. I hope it doesn't have the same face as Cassini. I was very angry about that and impressed. And I thought if I was an engineer on Cassini, I'd have been furious, but because they burnt it up in the atmosphere. But this one, the next spacecraft, they said it's going to do a much more rigorous photographing and using lasers and things and doing a topographical map of the entire planet in great detail. That's the plan. And fortunately, they've remembered very famous people, Lau, Reggio, I think that's nice. Hayabusa, the Japanese. So they've honoured everybody in all this, the IOU, which is really good. So why is Pluto red? You saw those three pictures beginning? And it's because the things called tholins. So what happens is UV light and cosmic rays hit the surface of the planet and they cause that stuff to sublimate as a gas, puff up, and then it changes colour and becomes it's a chemical reaction. And when it falls back down, it's red because it becomes hydrocarbons, which are molecules of carbon, hydrogen, oxygen.
At some stage between coming back down as a gas to a solid on the surface, does it form as a liquid rain?
We're coming to a different kind of rain. I'll talk about that in a moment. I don't think it will rain. Well, you mean like a snow?
No, I mean liquid. No, it doesn't.
No, I don't think so. It can't be a liquid in that because the atmosphere is so thin.
Triton's the only place where that's possible.
Yes, Triton. Triton's fascinating. So that's the plan. So cosmic ultraviolet rays interact with methane on the surface of the atmosphere and create that colour, that reddish colour you see. So far as they know, but they're not absolutely sure. So anything I write in red is doubtful. Well, is in doubt. Has not been established.
Give me concern over some of the other colours then.
Yes. Now, I love this. This is a real photo. Isn't it beautiful? A panoramic view of Pluto's icy mountains. They look like cloud tops, but it's a spectacular image. I just love it. Image by New Horizons. Imagine if Percival Lau was arrived to see things like this too. You know, these guys at Tombor. You know, they'd be thrilled to bits to see that. 15 minutes after its closest approach, distinct haze layers in the atmosphere can be seen backlit by the sun. So that's that stuff sublimating.
Are these photos in a visual wavelength?
Sorry?
Is it a visual wavelength?
I think so.
So I mean, the sun actually would be quite considerably brighter than Sirius. Because it's sunlight.
Probably enhanced.
Yeah, absolutely.
Maybe Midge, they've done something. Well, there's some stunt trials. Maybe they've enhanced these layers artificially to bring them out. Maybe special technique. I don't know.
I wouldn't expect that much light there, no.
No.
The other thing they do is they expand the vertical range of the topography. So
Oh yeah. Scale.
The scale they manipulate the vertical scale to make the topography look much more
It's very,
But
very low.
yeah, I've got a picture.
becomes more prominent.
I've got
Yes,
a picture
yes.
of this. See this area here? I've got a close up of that later on. So I think it's this, which I'll show you. So anyway, a beautiful picture. So anyway, if you want to, I won't stop. But if you click on those, you can actually watch videos of flying over the surface. It's fantastic, and they're all from NASA. Beautiful videos, really good video, worth watching. So just put Pluto in, and then you'll get these three fantastic little videos going over the surface by New Horizons. So now, what are the blue areas? The blue areas are water, where water has been found, water ice. So yeah, I didn't know into that. Regions where water ice has been detected, blue regions. So there is definitely water ice on Pluto. And that's, of course, New Horizons before it was sent off. Launched January 19, 2006. First spacecraft to explore Pluto and its moons up close. And there are some of the... they departed from convention and named some of the instruments on people's names. I suspect there were some of the engineers who were working on those instruments. So Alice, Ralph, I think that's really good. Instead of having those acronyms, you know, like the other things like Lorry and Swamp, they're all acronyms. Anyway, student dust counter. That was an actual experiment on where students want to know how much dust hit the spacecraft. So they took that with them, which I thought was rather endearing. So first their spacecraft to explore a second cosmic object, Arrokoth. Have you heard of Arrokoth? Here is Arrokoth. And it's got a red stuff on it too. But that's way out there in the Kuiper Belt. And they've actually taken a picture of that and they're all puzzled by it. They can't understand. I mean, it looks like two things fused together. But it's strange. Yeah. They call it a snowman.
It almost looks like a Neolithic carving.
Yeah. Amazing looking thing. Anyway, so that's further out, even further out. So here's another shot of that atmosphere and that sweating. Pluto's got nitrogen, methane, carbon monoxide, so it's got the building blocks of life, the hydrocarbons, and that's why you get that colour. And that's a near true colour taken after New Horizons flew past and looked back. So you've got the night side away from the sun. I think that's beautiful. Again, those layers. It was 200,000 kilometres away when I took that picture. So we've talked about sublimation, so we don't need to revisit that. Now I put these pictures in because today I didn't have them there, but I thought they were worth sharing. So the top one is the right is the polar region, and look at this. These are really amazing high-res photos. But that's that area I showed you where you had the big peaks and then the smooth area. And look at those polygonal shapes. They remind you of stuff on Earth. You know.
Sorry, I don't know if it was on an earlier slide, but underneath the red dusting, do they know what the lithology is under?
Yes, there's a picture, yeah. I think there was an earlier shot. There's definitely rock and ice. I don't know what the core is, probably just, I'm not sure about the core, but it's not molten, it's not very hot.
Yeah.
But there are moons that have evidence of stuff happening underneath. Yeah, which I'll come to shortly. But not Pluto. I don't think Pluto's pretty inactive geologically. Yeah. So now a bit of a story. These moons. So just looking at them, if you might be interested. I'll just put the last one on Hydra. So the order is like this. So Charon is the ferryman. Remember the ferryman? The ferryman, beautiful Greek words. The Charon is the ferryman who takes the dead across, the people who have died, the souls of the dead across the river Styx. There are 5 sacred rivers. One of them is Styx. All 5 end up in Hades, the underworld. And so Charon takes them across the Styx, and this is how to remember these. And in the night, Nyx is the goddess of night and darkness, known to Egyptians too, and in Greek, the spelling is N-Y-K or something, because I can't remember. And then you've got, what happens to you when you get there? You're greeted by these nasties, Cerberus or Kerberos and Hydra. Now you might remember Cerberus is the 3-headed dog, this massive thing, but it's not a normal dog. It's got manes like hair, like a lion, and then those manes are snakes. Snakes on its feet, snakes everywhere. And it's there to prevent people from getting into Hades. Now, why would you want to go to Hades? But it's also to prevent the shades of the dead from leaving. And so now, their concept of Hades was, or Pluto was Hades, same thing. Their concept of Hades was that if you were a good person, you still went there. You just lived in a part that wasn't so bad. Yeah. So everybody went to Hades.
It's like being here, isn't it?
Yeah. Anyway, the other monster is Hydra, which is a 9-headed snake. 9 snakes. Now, you might know your mythology because Heracles had 12 labors, Hercules, and 2 of them for the king, Eurystheus, whatever his name was to kill these monsters. That was the last labour, the 12th labour, was to get rid of these 2. And he didn't actually kill them. He had to bring this one, his last one, this is the 12th labour, he had to bring that back home to Eurystheus. Say, look, here's Cerberus. He said, you were helped, which he was actually by his nephew, I think, at one stage. Anyway, interesting story. I love all that sort of stuff. So, that's just a real made up eclipse. Where are we? So another picture of the moons to scale in terms of size and their rotational pattern. Here we go with those harmonics again, the equilibrium of those orbits. Notice that Pluto in the middle is moving. It doesn't sit there and the others move around it. It's moving because the barycenter is outside the planet, as we saw earlier. So there they are in colour. Pluto, Charon, Styx, Cerberus and Hydra. Now, does this work? I don't think it moves, but I can give it a go and give it a little tap on here because it's awkward here. And just to show you. Now look at Hydra. That's how it actually rotates. Yeah. And even Cerberus is a bit dizzy, but one of the worst ones is Nix. Nix is spinning around, they make you sick. So those orbital periods are just amazing. I mean, the outside one is just, it looks like something hit it, and it's kept its spin, which it would, short of not colliding with anything else.
That's a lot of fun.
Yeah, anyway, I thought I'd include that because it, I thought it,
Do we know how many times it rotates in a revolution?
sorry?
Do we know how many times it
Oh,
rotates?
they've got it there somewhere, yeah. I didn't want to put too much stuff in. Anyway, this is what happened with Pluto. It was hit, this is how the moon's probably started. The entire system was believed to be formed by a collision between Pluto and other Kuiper belt object early in the formation of the solar system. And so they've drawn it in the diagram there, debris ring, and there's Pluto accreting from it, and then the other bits and pieces around with the other moons. And a guy from the SETI Institute said, the moons form a series of neatly nested orbits, a bit like Russian dolls. And I thought, Russian dolls? I'm trying to get the analogy. I can think of nested coffins in Egypt, but not nested orbits anyway. Whatever. And that's just another diagram from 2012 to scale, showing the different actual images of it from Earth, not from obviously not from anywhere else. Nix and Hydra were found in 2005 by a Hubble space team. Cerberus found between Nix and Hydra, and Styx discovered in 2012. So these are pretty recent. Found by Gemini search of potential hazards to the New Horizons spacecraft. So no doubt they'll find other stuff out there that's very much the same. That's an actual photo. Pretty blown up and grainy, but still. Can't wait to see what James Webb does with all this. When it focuses on it. Now this is Charon. Now if you look at it, look at the top, it's got that same hydrocarbon residual deposit on the surface, and they reckon because it's almost like a dual dwarf planet, binary dwarf planet system, they're so close. In fact, they're only, I think, something like 120,000 k's apart. That's a third of the distance of the moon from the Earth. So you can see that they're pretty close, and because of the massive size, 50% of the size of Pluto, Charon, it's going to have a profound effect on the planet. And so when they interact, gravitation interact, and stuff coming off Pluto, when we talk about sublimation, probably lands on the surface of Charon as a result of their interaction. Look at this thing. Look at the size of that. Those cliffs. I will talk about those cliffs. Discovered by James, this is the story, I love this story. This fellow is in his 80s at the moment. There's a lovely video of him talking, yes, but holds up his he's got 2 plates. I really empathise with him. He's sitting there, he says, I was looking at this and I saw a lump. And he said, I looked at this and I saw another one. And he was studying Pluto and saw that over, I think it's a 6-day orbit, the lumps kept appearing around the edges. So Pluto didn't realise it was a moon. And so, now, the story is, how do you think of the name Charon? Because if you discover something, you're entitled to name it yourself. And he thought about his wife. And her name was Charlene. So he thought, Char-on. He put on the on, he had no idea what he was doing. So he said, oh, Charon, oh, that sounds scientific. And anyway, then he sat down and looked at a dictionary and realised that Charon was an actual mythological figure, the garden of the underworld. So, oh, this is really great. and so that was the story, and eventually it got accepted. Anyway, the chasm complex, thousands of kilometres of it, 9-kilometre high cliffs, 9 kilometres. In the video, he says, this could be 6 or 7 miles high. He's describing it, and I thought, oh, it's really nice little video. Go to watch it. Charon's surface is dominated by less volatile water ice compared to the other Pluto. In 2007, observations showed that suggested the presence of active cryogeysers and cryovolcanoes. Now, cryo suggests freezing and cold temperatures, but something's heated them. You know, like the ocean floor, when you get those geysers coming up off the ocean floor. That sort of concept. So something is causing these geysers, but then that's true of the other moons. I mean, you look at Enceladus and what's the other one? Europa. A good examples of things happening beneath the crust.
Volcanic vents.
Volcanic things. Well, yeah. So cryo. Where did I say? Where's that word? Cryo geysers, cryo volcanoes. So
It could be tidal forces because it is so close to Pluto.
precisely, and that's it in a nutshell. They are just so close. So it's the same as Io and Jupiter. Io is volcanic because it's so close to Jupiter. And you've seen Io, it looks like a pizza. It's got volcanoes going everywhere. The biggest one is Pele. Remember Pele ones? Huge green thing. That was discovered by an engineer. She was looking at pictures and she said, oh, there's a lump on Io, and it was actually a volcanic eruption. And there's another example of stuff that goes kaboom, and then just hits its ice, hits the surface cold, might go up into space and then freeze instantly and drop back down again, which is very interesting. Anyway, so larger than dwarf planet Ceres. By the way, have you seen pictures of Ceres? I can't believe how good they are now. Before it was just a speck. Now we've got beautiful pictures of Ceres, which when I was a kid was known as the biggest asteroid. There was Ceres, Vesta, Pallas, Juno. I think Ceres, yeah. And now it's it's quite big. Ceres is a big object, but it's the only non-Kuiper object in the asteroid belt that's so big. Ceres, massive. 12th largest natural satellite. Charon is even similar in size to Uranus's moons, Umbriel and Ariel. We talked about the dwarf double planet concept, and there's a nice little orbital picture which I won't put on. Orbit each other every 6.4 days. Now that's just something that as a kid, I never understood. But once you start reading about space, now you realise that things don't move with one thing stationary and the other thing going around it. There's always a tug. There's even a tug on the sun. So everything works that way. Charon has bright equatorial band. The North Pole region is dominated by an area called, I love this, Mordor. Informally, that's it there, Mordor macula, because it looks like you've got a macula in your eye, so they call it Mordor macula. It suggests that this is formed by condensation of gas, which I told you about from Pluto's atmosphere. In winter, the temperature is minus 258 degrees. What's that? That's about 15 or 16 degrees Kelvin or something, just above absolute zero. That is extremely cold. And these gases, which include nitrogen, carbon dioxide, and methane, condense into their solid forms. Then these ices are subjected to solar radiation, which I talked about before, UV light, cosmic rays, and then they become reddish solids. And hence, the same thing is happening there as it does on Pluto, virtually. And it's getting stuff from Pluto. Now, Neptune. How are we going to do it? Oops, I'm going to speed up. Okay, Neptune and its moons. So basic facts, 4th largest planet, 8th from the sun, mainly gases and liquids. But Uranus and Neptune differ from the gas giants because they are called ice giants. Their structure, internal structure is different. And so, and therefore you can't describe them as gas giants. But I used to, but they're not. They're actually considered to be ice giants. 17 times the mass of the Earth. Planet orbits once every 165 years, roughly, which is very slow. Now, temperature and pressure conditions are so extreme on Neptune and Uranus that carbon atoms could be crushed into diamonds in their atmospheres. So it would rain diamonds, which would bring the price of diamonds down considerably in the solar system. Neptune's atmosphere, like the gas giants, is actually hydrogen and helium, and hydrocarbons, nitrogen, but with a greater proportion of ices. So water, ammonia and methane, much more of those in ice form. Similar to Uranus, its interior is primarily composed of ices and rock, so it's not gaseous or even liquid. Both planets are normally considered ice giants to distinguish them from gas giants. Anyway, there are a few spots that appeared. I won't dwell on those, a bit like the Great Red Spot that appeared on Jupiter. But look at this. In addition, weather patterns are driven by the strongest sustained winds of any planet in the solar system, 2,100 kilometres per hour. You know, that's just mind-boggling. The speed. Anyway, because of its great distance, Neptune's outer atmosphere is one of the coldest in the solar system at minus 280 degrees. Temperatures at the planet's centre are approximately 5,400 degrees. It has a faint and fragmented ring system, which was discovered, and then Voyager actually took pictures of it. So we've just got a couple of quick pictures here. 80% hydrogen, 90% helium. Now, something weird. You know how you've got the ionosphere, and you've got a thermosphere and an exosphere. The thermosphere is, I think it's about 200 kilometres from the surface of Neptune. It's hot. It is 750 degrees. So I'd write all the mysteries in red. Now that's a mystery. But I've often thought, if you look at the sun's corona is millions of degrees, but the first surface of the sun is 5,500 or something. Or
That's
6,000.
a mystery as well.
Sorry?
That's a mystery as well.
Yeah. I mean, isn't that bizarre? But that's just a physical reality. So here we've got like a temperature inversion out there in the middle where you think it'd be freezing cold. It's 750 degrees Kelvin, which is what, 400 or 500 degrees. Anyway, sorry, to answer your question, the structure too. Mantle and core, so solids. Sorry.
I was going to say thermosphere. I think there's something about where you've got so few molecules out there anyway that measuring temperature is a different sort of thing than sticking a thermometer in a bucket of water.
Yeah.
So that it's sort of.
But even so, it's unusual, isn't it? It's extremely unusual. You can't sort of. It's an inexplicable thing. I mean, anyway, there are a couple of dark spots that appeared on Neptune. A Hubble Space Telescope observed things, and then one spot vanished. And there's a little image. Combined colour near infrared of Neptune, showing bands and the 4 of its moons. Anyway, now another spacecraft planet. We talked about the one for Pluto. There's another one. A Neptune Odyssey is a current mission concept for Neptune orbiter, and an atmospheric probe being studied as a possible strategic science mission by NASA that would launch between 2031 and 2033. So I think we ought to explore these things because we just don't know enough about them.
Wish we'd do it quicker.
Sorry?
I wish we'd do it quicker.
Yeah.
2049, hello?
Yeah. Yeah, it's the old mortal coil. What can you do about it? I love this picture. Like I said to you, I like art. And this is a shot from Triton, I think, painted from Triton. Some ice is evaporated, sublimating from the surface. I'll wait till you see this. I won't say anything. I'll wait till you see this moon I'm going to come up with in a minute. Fantastic. Nothing, not with Uranus, not Neptune. There's the ring system. So the moons of Neptune. So let's have a look at them quickly, and I'll race through them. Isn't that a beautiful shot? That's an actual shot of Neptune from Voyager from its flyby in 1989. So Voyager was launched in 1977. Got there. There were 2 voyages. One they went to Jupiter and Saturn, then took off, and the other one went further and shot out the solar system at an angle and reached Neptune, and then went out at an angle like that, at completely different angles. But Voyager 1 is the furthest one at the moment still, and it'll never be caught up. Voyager 2 will always be behind it. So Neptune has 14 known moons. I think in one of the pictures is a candidate one they've just discovered, so it might be 15. The largest is Triton, discovered by William Lassell. Now he's significant because the rings are named after Lassell and Verrier and another guy, the British guy, Adams, I think. And I'll tell you about that in the discovery of Neptune. Well, discovery in inverted commas. They say Galileo first saw Neptune, but didn't realise he was looking at a planet.
He thought it was a star.
Yeah, he thought it was a star. So it goes back a long way. So when you talk about the discoverer, but Verrier was a mathematician. We'll come to that. Verrier was a mathematician who predicted its presence, and then he got a guy called a German guy, Gall, G-A-L-L-E, actually found it for him. And at the same time, a guy in England, I think it was Adams, was working on the same thing and the same, but was a bit out. So in the end, they had a big argument. You know, the French and the British, they never get on. This is we had discovered this name. Can you imagine? You are one. Anyway, so they had the French-British conflict, and eventually they settled their differences and agreed that Verrier and Adams were joint discoverers. But there was an argument afterwards. How you work? You know, there was this sort of thing that went on afterwards. These scientists, you know, like you go back to people like Flamsteed, the Astronomer Royal, and these people, they didn't get on with each other very well. There's a very dark history with some of them, but anyway. So over a century before the discovery, the second natural satellite took place before they discovered Nereid. Anyway, Neptune's outermost moon there, so it's an orbital period of 27 Julian years is the longest orbit of a satellite around a primary in the solar system. 27 years. Anyway, there's a nice picture. That's the one that's been newly discovered down here. I can show you my little red dot. This little orbit here. The inner moons, Naiad, Thalasso's, Galatea, Despina, Larissa, I think they're all Nereids, water, named after water spirits. And Triton marks the boundary between the inner moons and the outer moons. So beyond Triton, you've got others, which we'll talk about in a second. Here we go. So now, all this does is talk about regular moons and irregular moons. Inner moons are regular moons. So looking down on their poles, they're rotating anti-clockwise and following the direction of Neptune. They're prograde. Irregular moons are doing the opposite. They're actually retrograde in rotation, or that means they're being captured. They're not actually part of the original system. So whereas the inner moons were probably from the planet, with the planet and part of it, the others were not. Triton is a very good example of that. So the irregular group consists of all 7 moons, the outer moons, including Triton. They generally show inclined, eccentric, and often retrograde orbits. So what does that mean? Instead of going this way, they're going that way. East to west instead of west to west. If that makes sense? As they go around the planet. So that's really unusual. That's sort of an indication of them having been captured and not part of the original system. Captured because of probably because of the Kuiper belt and the interaction, gravitational interaction between the bodies there, collisions, which we know nothing about at the moment. But the regular moons, the ones inner moons, are Naiad, Thalasso's, Despina, Galatea. Do you know Galatea? Does it ring a bell? Galatea. Anyone remember The Bicentennial Man, starring Robin Williams? What a beautiful movie. Have you not seen that? No. Well, yeah, it's a lovely film. Bit of a tearjerker, but a lovely film. Robin Williams just shines in it, and so do all the actors. They're all really good. And it's just about how humans eventually will become synthetic, have synthetic organs, and where do you define human and where do you define machine, and there's a guy in there, Rupert, who's a brilliant engineer, and he makes these synthetic organs. But Robin Williams' character does the opposite. He wants to become more human, so he chooses to be mortal. And that's what the whole story's about. I won't tell you any more about it, but it's worth watching. It's a really good film. But in it, there's a robot, a female robot called Galatea. And Galatea was actually a statue carved by a guy called Pygmalion, apparently, a Greek Pygmalion, hence the play Pygmalion, who fell in love with his statue, and he begged Aphrodite to bring it to life, and she did. Then they had kids.
And I think we have problems.
Yeah. But he fell in love with the statue. Apparently, the story goes that someone, who was it, carved a statue that was so beautiful they wanted to be locked up in the statue overnight. I'm not sure if it was that one. But anyway, pretty weird sort of stuff, you know. Anyway, so Galatea, very white, very pale, hence galaxy, Via Lactea, related to the word for whiteness. Okay, so the first 5 moons orbit much faster than Neptune's orbit itself, ranging from 7 hours to 13 hours. So they're faster than Neptune. Very close. I think we'll leave the rest for now. That's Proteus, one of the moons. The only decent photo of Proteus. And there's a complicated thing with showing the orbits. But if you want to look up here at the top, this diagram here, I've got that enlarged. But you can see up here, can you see Gale, Leverrier, Lassell? They're the 3 people involved. Well, you can't. Sorry, I'll show you a blow-up of that in a minute. But that's all the orbital. There are the other moons. Very small and great distances from the planet. Why is that dot star? Oh, okay. Neptune's entire moon. So I won't explain the diagram. It sort of speaks for itself, except for the top bit. So we're expanding the scale. We're going out to Triton and Nereid 10 times, and then way back at 100 times further away, you can see the moon system with the rings. So the rings are named after those people I told you about, Leverrier, Adams. Now you can see it. So the grey bits on the left are the rings, the ring system, and here it goes around here. So around here, and here are the inner moons. Hippocamp, we've got a hippocampus in the brain. I think hippocamp means something to do with a horse.
Yes.
A strange horse with a tail of a fish.
It's a saddle shape.
Yeah, with the tail of a fish. Anyway, I don't know if that part of the brain is shaped that way. But anyway, thalassos is a Greek word, I think, for sea or ocean. Anyway, let's move on. So they're the discoveries on the left there. And that is a shot by the James Webb Telescope of Neptune's rings in infrared. Wow. So, the planetary ring system, you've got the Adams ring. It just tells you a bit about the Gale ring, these rings, 42,000 kilometres away, 63,000 and so on. That reddish hue again, we're getting that reddish hue. Anyway, I won't go on the ring system. And there are those inner moons by comparison to their size and comparison to the planet.
I think the rings are dust, aren't they?
Sorry?
The rings of Neptune are dust.
Yes, but they're different colours.
They're not ice or...
No, they're particles.
Yeah.
Material, yeah. I mean, probably got ice on them. I wouldn't be surprised, given how much ice there is. Consists of ice particles coated with silicates or carbon-based, giving them a reddish hue. Hang on. Irregular moons, the ones I told you about, the 5 outer ones, they go in a retrograde orbit. So we've already covered that. Triton's orbit is nearly a perfect circle. They're the largest. Triton and Nereid are the largest irregular moons in the solar system. And there's a picture of Triton's orbit around Neptune, which dips down quite steeply, a bit like Pluto does in relation to the ecliptic. Now look at the mass distribution. Triton is virtually the whole mass of the moon system, and all the other moons fit into that little red sliver. So it's pretty massive. And that, I think that's another enhanced picture of Proteus. I think it is. Not Nereid, it's not Nereid. Nereid's tiny and it's a blob. It hasn't been researched, you can't even see it. Now you might recognise this beautiful moon Triton, here it is. Because of its retrograde orbit and relative proximity to Neptune, tidal deceleration is causing Triton to spiral inwards and decline, to answer your question. So eventually, 3.6 billion years, bang, just like binary stars or getting too close to each other. And its mass is so big that it would have that profound influence. Surface features include a southern polar cap, grabens and scarps. Do you know about grabens? you know, if you know any geology, you know when you get a fault, a bit of the land drops and a bit rises, you can get that sort of slippage. So the bit that rises is called a horst, the bit that falls is called a graben, and the cliff face is called a scarp or a scarpa. And they're everywhere on a lot of the moons, as we'll see. So you've got grabens and scarps, and you've got that word again, cryovolcanism. Voyager observed a number of active geysers within the polar cap heated by the sun, which eject plumes to a height of up to 8 kilometres. That's amazing. High density, what else can we say about it? I think we'll leave the rest. But it's a small amounts of methane, carbon dioxide. It was discovered to have a substantial atmosphere, which is primarily nitrogen. What would And now this, of course, is Uranus, so it's a real picture by Voyager of Uranus. So that's natural colour. And it's got a kind of a pale blue hue to it. That's a nice picture. I've just put that in the gratuitous thing because I like it. Named after the Greek god Uranus, Kairos. On my Roman armour, the god at the top of my Roman armour is Kairos, the god of the sky and the heavens. Father of Kronos and grandfather of Zeus and great-grandfather of Ares. Similar in chemical composition to Neptune, not Jupiter and Saturn, and thus distinguished as an ice giant. Hydrogen, helium, but also lots of ices, water, ammonia, methane, and hydrocarbons, as we talked about before. First planet found was discovered in 1781 by William Herschel, son of the father of John Herschel, I think. Although he originally thought it was either a comet or a star. 2 years later, the object was accepted as a new planet. Herschel tried to name it Georgium after King George III, but instead they adopted the name Uranus. Anyway, it rotates once every 17 hours, 84 Earth years to go around, a complex ring system, but this is what gets me. Its unique tilt, because Uranus is tilted over, so it's actually, excuse the charade, but its axis of rotation is pointed in the direction of its revolution around the sun. So the equator is at 90 degrees to the ecliptic, virtually. So it's at a right angle. So any moons going around it are going to be at 90 degrees to the ecliptic as well. So talk about a weird setup. Just think you're going to follow that concept? 90 degree angle. So what does this mean? For nearly a quarter of each Uranian year, now don't forget there's 85 years roughly, nearly a quarter, that's 20-something years, the sun shines directly over each pole, plunging the other half of the planet into a 21-year-long winter. Each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness. Wow! And imagine life forms evolving under those conditions. Anyway, that's a simulated view of Uranus from 1986 to 2030. From the southern summer solstice in 1986 to its equinox in 2007, and then northern summer solstice in 2028. And I won't read you, all the numbers are at the top there, they've got all the years going by. But wow, isn't that amazing? So it's got a tilt of 97.77 degrees. And that's what causes the unusual conditions. Its upper atmosphere experiences strong winds in the direction of rotation. At some latitudes, such as 60 degrees south, visible features of the atmosphere move much faster, making a full rotation in as little as 14 hours. So parts of it are spinning faster. Features of it are spinning faster than the planet itself. The outermost layer, the thermosphere and corona, has a uniform temperature around, remember we talked before about Neptune, 800 to 850 degrees Kelvin. The heat sources necessary to sustain such a high level are not understood. So anything in red means it's a mystery. Because neither the solar UV nor the auroral activity can provide the energy to maintain those temperatures. It has a peculiar magnetic field, but that's because of its tilt. The magnetic field is tilted 59 degrees from the axis of rotation. So you end up with, I'll just show you this kind of thing. Very strange, isn't it? So the light blue arrow marks Uranus's magnetic axis, the dark blue one its rotation axis, and the yellow one points to the sun as it's going round. And you can see the structure of this is just like Neptune, with a hard core, an ice planet, not a gaseous one, as far as we can tell you. All right. And there are actual shots of its rings and an aurora on the planet, taken by, what is it? The Space Telescope Imaging Spectrograph on Hubble. So not by Voyager, of course. Where are we? There was a dark spot observed on Uranus as well, but it's fairly featureless. Has two sets of rings, the inner system of 9 rings, narrow dark grey rings. Our innermost one is red, like the dust rings elsewhere in the solar system. The outer one is blue, like Z ring. And there they are. They're the names of the rings: Zeta, 654, all in order outwards. There are 13 of them. Some of the larger rings are surrounded by belts of fine dust. The rings are composed of dark particles, which vary in size from micrometers, millions of a metre, to a fraction of a metre. There are aurora on, there's a beautiful shot of an aurora on Uranus. And it talks here about the cap and collar, which are these features. And I think there's something in the news at the moment about that. And this is more like a fog, a smog. We call it like a smog that appears around the polar area, which they're still trying to figure out. Right southern polar region. The northern one is quite dim. So they call them collars, southern collars. Anyway, Hubble Space Telescope images those. And the rings, just very quickly, just pictures of the rings. An infrared composite image from Earth, from the Keck telescope. The rings are probably quite young. Outer rings, blue colour, I've already mentioned that. I don't think we need to, I'm just going to skip through this because we've already discussed it. Usually a few kilometres wide, all except 2 rings. 13 distinct rings, the brightest being the Epsilon ring, which I think was the innermost one. And I put that in there because I just love this picture. Imagine being on a planet like this one, on a moon, and looking back at the planet. It's fantastic. I love this sort of these works of art. So the moons of Uranus. Now, does anyone know what moon that might be? It's my favourite one. It's a small one, but it's Miranda. Now, these moons are named after, here they are, these are the bigger ones. Miranda's the smallest of the bigger moons. Ariel, Umbriel, Oberon, and there's also Titania. All fairies, except for Miranda, from A Midsummer Night's Dream by Shakespeare. So they're all named after Shakespearean characters. So, and the other ones, some of those were, here we go. Oberon and Titania, the largest moons, first to be discovered by William Herschel and William Lassell, who of course found Triton. The Voyager 2 spacecraft visited Uranus in 1996, tripled the number of known moons. They got an additional 10, and then Hubble, we've now got 27. So Uranus has 27 moons. All of Uranus's inner moons, those observed by Voyager 2, appear to be roughly half water ice and half rock. There's a lot of water out there in the solar system. So if we ever have trouble, we can go and mine it and bring it back. Fresh water. There'll be a boundless supply of it. The composition of moons outside the orbit of Oberon remains unknown. They're likely captured asteroids. So there they are in order, and it's this one here, this beautiful little one down here, which I'm going to show you some pictures of in a minute. I hope. Oh, sorry. The moon's in order. Puck, a fairy from Midsummer Night's Dream. I love that they're all, Miranda is not. Miranda is a character from As You Like It, I think. Ariel and Umbriel, yes, and Titania are all in Midsummer Night's Dream. And there's a beautiful shot of the planet as it Voyager went past it. 1 million kilometres from Uranus when it took this picture. So, the one behind me. Very close, almost finished. And there's a picture of the ring system, and you've got the rings mentioned there, 5 Beta, Gamma, Delta, all those different constructions. And then the inner moons, and then another ring system, and then the outer ones at Rosalind and all those, Cupid. Where is that? Rosalind. Was Rosalind from As You Like It? I think, I'm not sure. I believe that is from a character from Pope's. Is that the woman in Pope's, the Rape of the Lock? Which was a comical or burlesque poem about a guy who cuts off a bit of hair from his girlfriend, Belinda. I think from the Rape of the Lock. Rape, not rape in the sense that we've come to know, but to seize. Bit of Latin, rapio, rapere, rapui, raptum. Sorry, I've just conjugated the verb. It means to seize or grab. So he grabbed her hair and cut it and kept the lock. I don't know why. And there's 720 lines of verse in poem, something like that, in Pope's poem. It's massive about this. So he sets, he just mocks it all.
Richard, you could say anything. No one here is going to dispute what you
Oh, you can do that.
Sure, you understand.
You could be talking a whole lot
Thank
of
you for that
rubbish.
vote of confidence. Anyway, 13 inner moons, orbits lie inside that of Miranda. So Miranda marks the border between the inner moons and the outer moons. Anyway, so let's have a look at the mass distribution here. You can see Miranda's tiny compared to Miranda's that little dark blue bit there. But Titania is Titanic. Umbriel is the green, and Oberon is this one here. So they're pretty big moons. They contain most of the mass. All of the inner moons are probably fragmented from smaller moons. That's all they are, just fragments. So Miranda has only 0.7% of all the mass, Titania almost 40% of all the mass. And now we're just going to, I won't talk to you about the moons anymore, but I'll just put in a couple of pretty pictures, artists' interpretations. And that bottom one is a view of Uranus from Miranda. And I'm just going to show you, if I can, oh sorry, that's just another picture of what we're looking at. They're actual photos, but all, what do you call it, just put together to show you a comparison. 472 kilometres is Miranda on the right there, the smallest, and Ariel's the brightest, Umbriel's the darkest, the biggest albedo is Ariel. Yeah, I haven't, there's so much about these moons now. You could read and read and read forever. There's a bit about all of them here, but they're tidally locked, Titania, tidally locked, so they keep the same face. And like the moon keeps the same face to us because it's rotating at the same speed as it takes to go around us. So we always see the same face. So let's just draw a lot of these tidally locked moons. I'll wait for this. Miranda, the innermost and smallest, has a surface unlike any other moon. It has a giant fault canyon, it's like that lovely picture I just showed you, as much as 12 times as deep as the Grand Canyon. So Mariner Valley on Mars is nothing compared to what this little moon has on it. Anyway, we can leave the others, I think. But there's some fascinating stuff here called Year and Ophelia shepherd moons that affect the rings, you know, like they do around Saturn. Some of the moons affect the shepherd moons. Between them and Miranda is a swarm of 8 small satellites. They may be shepherds for the planet's 10 narrow rings, and scientists think there must still be more moons interior to any known to confine the edges of the inner rings to keep them in that shape. Titania is the size of Australia in terms of surface area and takes 8.7 days. Its rotational period is synchronous, so it's tightly locked. Jared Kuiper, the guy for the Kuiper Belt, found Miranda in 1948. Now Miranda, oh sorry, that's a picture of the rings, what we had in the last one, with Neptune, and the spread of the innermost satellites, and there they are, those ones there. Does that make sense to everybody? And the middle one is the bigger moons. Wonder it doesn't. Look. Now, this is Miranda. I find this absolutely fascinating. See this. This cliff is 20 kilometres high. Okay? Now, the force of, I found out, looked up, surface gravity is 0.077 metres per second. Acceleration due to gravity. So, how long would it take you to fall? I'll do the calculation. For those, to take a dive off the top of that cliff, imagine if you could actually float down. What a journey to get to the bottom of it.
You can go the other way around. You can jump from the bottom to the
top. But what an incredible 20 kilometres. I mean, that's how many feet is that? Kilometre is 1,000 metres. It's 3,000, 60, 70,000 feet easy. Wow, that's well beyond where the jumbo jets fly, twice the height. So that's just a single cliff. So this is signs of what we're talking about before: horse grabens and scarps. So there's been a lot of cracking of the surface, and they reckon the thing that's causing it is like a welling beneath, you know, just like you have on maybe Europa and places like that, suggesting that something is going beneath the crust. Other scientists think, though, that it's been, this is what it used to be believed. It was a hodgepodge of things brought together. These things are called, like chevrons, are called coronae. A corona, something that's oval shaped, is called a corona. There are 3 of them. And Verona Rupes, I don't know which of those it's in, but look at there they are on the bottom: Elsinore, Inverness, and Arden. Arden, as in Arden, Shakespeare's wife. Inverness is very Scottish. And Elsinore Castle or something. Elsinore, that's familiar somewhere. So anyway, I love that idea of, you know, parachuting off, if you had an atmosphere, parachuting off the end of that cliff. And there is one of those close up. I think this is Elsinore. Yeah, Elsinore Corona, there it is. Look at those huge gaps. So if you could stand in those, it'd be just mind-boggling. Those would be 10 kilometres wide. A single line would be 10 kilometres wide and many kilometres deep.
Isn't that square geometric shape a little unusual?
Yes, it is. Highly unusual. You know, but then when you look at patterns of things like convection patterns and things, you often get circles or ovals.
Yeah, you would expect that to be oval.
Yeah, but they reckon it's caused by, it's not caused by compaction, it's caused by, you know, continental drift, tearing, movement apart, and that's why you've got those big jagged valleys and things. I was reading about it, and they reckon it's caused by that kind of tension. The same thing as tectonic plates being pulled apart on the Earth. You know, the Mid-Atlantic Ridge forming because the 2 plates are pulled apart. Yeah. So we come to the end. Here is Voyager, and that's where Voyager went. So Voyager took all those photos, most of the early ones, and you can see Voyager 1 is still working, but well beyond the helipause now, so well beyond the sun's influence into interstellar space. Voyager 1 is ahead, and Voyager 2 had left the system in 1989. So, yeah. Anyway, to end on a note of humour. No doubt about it, Ellington. We've mathematically expressed the purpose of the universe. God, how I love the thrill of scientific discovery. And it's your own. He just hits the spot. They go nice. Anyway, that's it, folks. So thank you very much.
Fantastic.
I'm sorry, there's so much stuff on these things, and you end up getting sidetracked. You know, like I found out.
Richard, you get sidetracked.
Never.
Unbelievable.
My students at Elizabeth College, they used to know I loved astronomy, And they would say, Richard, what's that star? And I'd keep looking out of the east every morning. And off I'd go, and I'd think, I know what you're up to. Forget the English, we're going to do some astronomy. Or forget the ancient history, we'll do some astronomy. But anyway, yeah, so...
You know, Richard, you've been talking for 3/4 of an hour.
I know, it's shocking, isn't it?
And you know, I've learned 3 things.
I talked too much. That was too long.
No. That's as much as my brain absorbed and remembered.
Oh, gee. Anyway, lights on, let's have a drink or something.
Was it?
Hour and 10.
Just keep this low.
Hour and 10 minutes.
Hour and 10 minutes.
Oh,
Just keep this
Hour
Hour and 10.
How many students?
What are you doing? We're live streaming to YouTube.
Does anyone want to use this for anything?
Oh, to YouTube, so
No.
So the Astronomical Society has a YouTube channel. Yeah, and we're just live streaming the talk.
to which channel?
To the Astronomical Society.
In where? Here?
So the Astronomical Society has a YouTube channel.
Oh, right. Aren't you clever?
And yes, I might just turn because we can probably hear us talking.